What if the enormous wall of ice at the edge of Antarctica wasn't the end of the world you knew? Imagine a ship moving through freezing Southern Ocean water when the fog suddenly opens. Ahead is a colossal vertical wall of ice. But there's something strange. A massive opening cuts through it. And beyond that opening, another frozen barrier appears in the darkness. It looks like one wall was hiding another. It sounds impossible. But here's the important question. What would actually be there if you could pass through an opening in Antarctica's ice? Not another secret continent. Not an unknown civilization. Something far more fascinating. A landscape that has been hidden beneath kilometers of ice, connected to a continent larger than Europe, surrounded by an ocean that plays a major role in Earth's climate system. And the real Antarctica is already strange enough, without inventing anything. The continent covers nearly 14 million square kilometers, and its ice sheet can reach about 4.8 kilometers thick. Almost all of the continent is covered by snow and ice. So when you see a gigantic Antarctic ice cliff, you're not necessarily looking at the edge of the continent. You may be looking at an ice shelf, and that distinction changes everything. Because behind, beneath, and beyond those frozen structures is a world of moving glaciers, mountains, deep ocean water, hidden bedrock and landscapes scientists are still working to map in detail. So what would happen if that apparently impossible opening really appeared? Let's follow it. And by the end, we'll get to the part of Antarctica that genuinely looks like another world. First, forget everything you've seen in fictional maps of an Antarctic ice wall. Antarctica isn't a flat sheet of ice sitting at the edge of the planet. It's a continent, a gigantic one. Under the ice is rock, mountains, valleys, and geological structures. The Antarctic ice sheet is essentially a continental glacier covering almost 14 million square kilometers. In some places, the ice is several kilometers thick, and around much of the coastline, glaciers flow outward and become floating ice shelves. That's where things can become visually confusing. An ice shelf is thick glacier ice that has flowed from land and spread out over the ocean. Some Antarctic ice shelves are hundreds of meters thick. From the ocean, the front of one can look like an enormous frozen wall. But it isn't a wall surrounding the planet. It's the seaward edge of floating ice. And there are many of these shelves. The Ross Ice Shelf, for example, is the largest ice shelf in Antarctica and is roughly comparable in area to Texas or France. Now imagine approaching one. You're on the ocean. The horizon is almost completely white. The ice rises hundreds of meters above the water. You might naturally think, that's the end. But the ice is actually part of a much larger system. Behind it can be glaciers flowing from the interior. Under it can be seawater. And beneath the grounded ice is the hidden Antarctic landscape. So if an opening appeared through an ice shelf, what would you expect to find? It would depend entirely on where the opening was. You might see ocean. You might see more floating ice. You might see the underside of the shelf. Or, farther inland, you could eventually reach grounded ice covering the continent itself. There's no evidence of a second hidden world beyond Antarctica. But the real geography is already complicated enough to create something that looks almost impossible. And that's where the mystery begins. Now imagine our hypothetical opening becomes enormous. Satellite images show a dramatic break in the frozen structure. Two towering ice faces stand apart. Between them is a dark passage. And beyond it, another huge wall. At first glance, it looks like Antarctica has layers. But here's the scientific reality. Antarctic ice is constantly moving. Ice shelves aren't permanent structures. Glaciers flow toward the coast. Ice shelves spread outward. Cracks develop. Icebergs break away in a process called calving. NASA has documented enormous rifts forming and propagating across Antarctic ice shelves. The Brunt Ice Shelf is a particularly striking example, where major cracks eventually led to large iceberg calving events. So an apparent gateway through an ice barrier wouldn't automatically be evidence of something beyond Antarctica. It could simply be a fracture or a calved section of an ice shelf. And the scale can be enormous. NASA notes that Antarctic ice shelves can extend for hundreds of kilometers and reach thicknesses approaching several kilometers in some locations. But there is another reason the landscape can look deceptive. Ice shelves can hide what's happening underneath. Warm ocean water can circulate beneath floating ice, melting it from below and creating channels and cavities. Scientists have observed this process around Antarctica. NASA describes how ocean water can flow beneath ice shelves and erode them from below, thinning the floating ice. So a giant opening isn't necessarily an entrance to something unknown. It may be evidence of an ice shelf changing shape, and that distinction is critical, because the real mystery isn't what's beyond the wall, it's what's happening underneath the ice, and that question is much harder to answer. For decades, Antarctica was one of the least accessible places on Earth. The problem wasn't that scientists didn't want to explore it. The problem was the environment. Extreme cold, violent winds, huge distances, thick ice, dangerous sea conditions, and enormous areas that are almost impossible to reach directly. That's why satellites became so important. Modern instruments can measure ice elevation, movement, and changes across enormous regions without requiring researchers to physically stand on every kilometer of ice. NASA's ICESat mission, for example, helped scientists distinguish grounded ice from floating ice by measuring subtle elevation changes caused by tides. Think about what that means. A satellite can detect that one section of ice is rising and falling with the ocean tides, while another section remains fixed. That tiny movement can reveal where floating ice ends and grounded ice begins. So when scientists map Antarctica, they're not simply looking at a photograph. They're combining radar, laser measurements, satellite imagery, aircraft observations, GPS, ocean measurements, and geological information. And here's a question for you. If you could see through the entire Antarctic ice sheet right now, what do you think you'd find? A flat rock surface? Mountains? Huge valleys? Something else? The answer is surprisingly dramatic. Scientists have found that Antarctica contains extensive mountains, deep basins, valleys, and geological structures beneath its ice. The Transantarctic Mountains, for example, divide East and West Antarctica, and in West Antarctica, much of the bedrock lies below sea level. So the landscape beneath Antarctica isn't boring. It's a buried continent, and we're only able to see parts of it indirectly. Here's where our imaginary opening becomes scientifically interesting. Suppose the ice wall splits apart. Instead of revealing another continent, it exposes the transition between floating ice and open ocean. Suddenly, you're looking at something scientists care deeply about: the underside of an ice shelf. It might seem like solid ice from above, but underneath, seawater can circulate through enormous cavities. And those cavities matter, because ocean water isn't necessarily at the same temperature everywhere. In parts of Antarctica, relatively warm, deep water can reach the continental shelf and flow beneath floating ice. That water can melt the ice from below. NASA has used ocean and ice models to show how water moves beneath ice shelves, eroding their undersides and creating channels. Imagine the scene. Above you, hundreds of meters of ice. Below you, dark seawater. And between them, a hidden boundary that is constantly changing. You wouldn't see a giant tunnel leading to another planet. You'd see an active physical system: water moving, ice deforming, glaciers feeding the shelf from behind, cracks developing, and eventually, pieces of ice breaking away. This is one reason ice shelves are so important. They act as a kind of buttress. They slow the movement of inland ice toward the ocean. When an ice shelf weakens or retreats, the glaciers behind it can accelerate, sending more grounded ice into the ocean and contributing to sea level rise. So that fictional gateway suddenly has a real scientific equivalent. It's not a doorway. It's a boundary in a dynamic system, and that system affects the entire planet. But here's where it gets really interesting. Imagine the camera passing through our fictional opening. You expect to see another enormous ice wall. Instead, the camera descends. Below the ice is darkness. Then the darkness begins to reveal shape: mountains, valleys, ridges, and a vast landscape buried beneath the ice. This isn't fantasy. Antarctica really does contain a hidden topography beneath its ice sheet, and some of it is extraordinarily deep. The British Antarctic Survey reports that Antarctica's ice can reach nearly 4.8 kilometers in thickness, while geological mapping has revealed major variations in the bed beneath it. One especially important feature is the Bentley subglacial trench in West Antarctica, where the bed lies far below sea level. That means Antarctica's surface can be profoundly misleading. You can stand on what appears to be a flat, endless ice plain, while several kilometers below you lies a completely different landscape. And scientists are still improving their maps. Radar can penetrate the ice and reveal the boundary between ice and bedrock. Aircraft can survey huge areas. Satellites can measure surface elevation and movement. Models can combine those observations to reconstruct the hidden terrain. Suddenly, the phrase, "world beneath the ice," doesn't sound quite so fictional. But we have to be careful. A buried mountain range isn't a secret second world. A subglacial valley isn't evidence of an unknown continent. And an opening in an ice shelf doesn't prove there is anything hidden beyond it. This is where science separates an exciting image from a real discovery. The question isn't what we can imagine. It's what the measurements allow us to conclude. And sometimes the measured reality is more astonishing than the story. Now let's go deeper. Antarctica isn't just a frozen landscape. It's part of a planetary machine. The Southern Ocean surrounds the continent and connects the major ocean systems of Earth. Cold, dense water formed around Antarctica contributes to global ocean circulation. And the ice itself stores an enormous amount of fresh water. The Antarctic ice sheet contains roughly 60% of Earth's fresh water, according to the British Antarctic Survey. That makes the stability of the ice sheet important far beyond the South Pole. When floating ice shelves melt, the immediate effect isn't the same as dropping an iceberg into a glass of water. Floating ice is already displacing seawater. The bigger sea level concern comes when weakening ice shelves allow grounded glaciers to flow faster into the ocean. And West Antarctica is especially important. Much of its ice rests on bedrock below sea level. Some of that bedrock slopes downward inland, a configuration that can make retreat particularly difficult to reverse once grounding lines move inland under certain conditions. Now look back at our imaginary ice gateway. That giant opening isn't revealing another world. It's revealing how dynamic the real one already is. Ice isn't a wall. It's a flowing material. Ocean water isn't simply sitting beside it. It interacts with it. And the bedrock isn't simply flat ground. It's a three-dimensional landscape controlling how glaciers move. If that changes, the consequences don't stop at Antarctica. They can influence global sea levels, ocean circulation, and ecosystems. If this changed the way you think about Antarctica, hit like and subscribe for more science stories that separate the real mysteries from the myths. Now pull the camera back. Far back. The enormous fictional opening disappears into the landscape. The ice shelf becomes a thin line. Antarctica becomes a white continent. Then Earth appears. And suddenly, the scale becomes clear. Antarctica isn't an isolated frozen wall at the bottom of a map. It's one component of a planetary climate system. The Southern Ocean surrounds it. Winds and currents move around it. Sea ice expands and contracts seasonally. Glaciers continuously transport ice toward the coast. And ice shelves grow, flow, and calve. In winter, the area of Antarctic sea ice can expand dramatically, temporarily making the continent appear much larger from space. But sea ice and the Antarctic ice sheet are not the same thing. Sea ice is frozen seawater floating on the ocean. The ice sheet is accumulated snow and ice resting on land. Ice shelves are mostly glacier ice that has flowed from land and become afloat. Three different forms of frozen water. Three very different roles. And this is why an image of a huge ice wall can be misleading. A photograph shows you one surface. Science tries to reconstruct the entire system. Under the surface, below sea level, across centuries, and even across geological time, Antarctica contains evidence of climates dramatically different from today's. Its ice preserves bubbles of ancient atmosphere. Its rocks preserve clues about the continent's geological history. And its buried landscapes record the interaction between ice, water, and rock over immense periods. So maybe the most astonishing question isn't, what is beyond the ice wall? Maybe it's, how much of the world beneath the ice have we still not seen directly? Drop your answer in the comments.